Welcome to lesson 8. And yeah, well, the end of week 2, we've done quite a lot. We've gone quite a way. A nice way to finish off the week. So I'm going to talk about some aspects of writing programs. Particularly, we're going to start looking a little bit at security as well. So that's a good thing to start with. Um, but also we'll look a little bit about PDAs as well. Okay, so. We've spoken about the idea of ownership. There's a number of concepts here, so it's easy to kind of get them confused. So I need to sort of go through and explain them a little bit more. So the first thing, yeah, don't confuse ownership when I'm talking about Solana accounts with ownership that is what we have in Rust. They're completely separate things. It's just unfortunate that they use the same name. But we do have this concept of accounts having an owner, and the owner of an account is who can modify the state. So the thing we're expecting is to have a program owning an account. That account is holding the data for that program, and so the program is able to change the state, update the state in that program, which is kind of what you'd expect. You'd expect it to work that way. And the behind the scenes, there's a way that there's mappings being held to work out who can update which accounts. Um, so yeah, this and you've seen this type of thing when we had an initial program, we had an example program in Solana Playground, and we did an initial check looking at the owner of an account there, and then checking whether that was the program ID. Okay, so that's the first check that you can do. So that is really showing that we've got an account that this program can update. So that's a start, and certainly something that we need to check. But then there is more to it than that because, okay, that means yes, this account belongs to this program. This program can change this account, but it doesn't mean that the person who started the transaction, who sent the instruction that is being processed, is allowed to do anything. It could be, yes, they've called the correct program and they've sent the correct account, but actually they're not allowed to change it. They're not allowed to use the program in that way. So there are more things that we need to think about. And so that aspect of whether the person who is calling the program, who started the transaction, whether they are allowed to cause the or to get the program to update the data, that is the concept of authority that we need to have. Okay, so uh, the way that we can, uh, one way that we could do this is to work out some roles within our program. It can get a bit confusing because people tend to use the same names for these and sometimes call things owners as well. So it can get a little bit confusing. Um, but you can start to write this into your program and start to do checks. So for example, we've got this an example here with a struct. So this struct would be or could be used to specify the data in an account. And then within that, we've got some value that's going to be updated. But also we've got a public key to say that this is who has authority to do this. So this is an additional check. It's not looking at the owner which is going to be the program, but it's saying, who started this transaction? Do they actually have the authority to do an update? Um, and so you could do something like this within your code. So you if you remember when we get the accounts, we have to loop through them. There could be multiple accounts being sent into the program. So we need to go through them. So to do that, we can use an iterator. And then we can pull out the next account. So this, again, is a very simple thing I'm showing here. It's not necessarily the best way to do this yet, or there are probably other things we want to do, but this is just to illustrate the way that we could use authority. So we've pulled out the first account and we've said that's going to be the number account. And then now that we've got that and we've got the data that is being defined by this struct, what we can do then is to look at the person who called the program and check whether that person, whether their key is the same as the thing that we've got stored as the authority. So this is doing the check to see if that person is allowed to do this update. Also, we're checking whether they're a signer, because when you are submitting the accounts to the program, then you need to have signed for those as well to when you're doing the update. So we can do that, and then if all of that is correct, then we can change the value that we have in the account, so we can do the actual update. Okay. Um, the this example here is showing how things can be a little bit different with a PDA. I'll just go through this because it it is slightly, it can simplify things slightly. So in this particular instance, we've just got the data that we want to update within the account. Then what we can do is as before, we get the account out of all of the accounts that have been passed in. So that's the same as before. But then what we're doing is working out an address that is this. It is a PDA. So we're working out that special address, and we're deriving that. So this number PDA is deriving the address, but this is based upon the person who called who started the transaction, based on the caller. So it's similar to the way that we can create a PDA based on the program ID, but in this case we can base it also on the caller. And then with that will identify the the caller for this particular account, and so that is associating them with a particular account. So we've kind of got the authority built in already, and so in that case we can do the check. We do the check again here, checking that the caller is a signer, and that the value here makes sense. And then if that's okay, we sorry, someone said they're seeing a blank screen. Okay, nothing's actually be okay. Uh, if everything's okay, then we can update the account. Okay. All right. So I just mentioned this because just to illustrate there are different ways to do things. One point about this, though, well, it illustrates the fact that when we can derive addresses, so we can use this PDA mechanism to find addresses, to find these special addresses, and that can be done in different places, but it is deterministic, so it is something that can be repeated. It can be done, in multiple places, and yeah, it may be that would simplify your program. Okay, but that's just to show you an example. It's probably the first way is the way that you would want to do that initially. And certainly when we look at Anchor, we'll see that there are also ways that you can sort of simplify this as well. But before we get there, something like this may well be the way that you would want to uh, specify the authority of who is allowed to update a particular value in an account. And of course, you can make this as complex as you like. It's just then that in the program obviously you've got to follow the logic that you want for that. Okay. All right. So that's just the first thing to say about security. We're going to come on to some more points later on as well. Now, I want to mention the possibility of upgrading programs. You may have seen in the Solana program that you can do that. Sorry, the Solana playground. You may have seen that that's possible. So it is possible to upgrade the account the programs because they're an account. You can upgrade the bytecode within that, but there are some things to think about. So there is maybe a conceptual problem or a general problem you should be aware of that people tend to think of the code on a blockchain as being immutable, and and they think this is one of the advantages of having programs on a blockchain because that means it can't be hacked and there's security guarantees about this. So if you are if your program is upgradable, this means that you don't quite have the same guarantee. So the people who are using your program it's better that they are aware that this may be upgraded, and it's better that you are very transparent about this to try to make sure that they're confident that there's not going to be something malicious done because a malicious developer could, do something, uh, lull the clients into a false sense of security and into getting involved with a program, and then upgrade it to do something else, and potentially steal funds or whatever. So the best thing is to be very transparent about this and very clear about this so that your users know what to expect, and they'll know that you're not going to do some kind of rug pull. But there's details here about upgradability. There's a link there to an article about this. Um, the yeah, this is just So we can update the bytecode, and with this program data account. Uh, the buffer accounts, these are there to store the bytecode as this is happening. Okay. The way to do this, well, it's simple from the command line. So we'll have done a deploy, and then you can use that again to redeploy. One thing to be careful about is that when you are doing the when you're deploying, the account is created to be twice the size of the original deployment. So you'll get this extra space available to you, so that if you want to upgrade it, there's space for that. But that does mean that you'll have to think about the future a little bit, because if your initial program is very small and then you're planning later to do an upgrade and the program is going to grow more than twice the size, then you're going to have problems. So um, try to think about that when you do your initial deployment, and think about the potential future size. Um, and you can also specify this flag on the command line as well to give it to allow the system program to create an account of the correct size, if you're expecting it to be a certain size. Okay, so that's upgradability. Um, Program flow. We've we've gone through this in very general terms, and I gave some very simple examples. But I want to go through a more complex example now to give you a feel for how some of the code works. Um, so just to remind you, the usual flow can be broken down into the entry point of the program, then processing the instructions. We will then have some business logic, we will have access checks, etc., which will all result in some changes to state. And so we have to have the account handling code there. Okay. The main business logic, the access checks, all that kind of thing, tend to happen in the processor module. Um, but I'll go through an example here. This is how the mint token account it gets created, how we do a mint. And if you're this is in the token program, the link there to the source code. But I'll talk you through some parts of it so you can see what it looks like in a more complex example. So to start off with, we have our familiar entry point here. So we've got a function called process instruction, and then above that, we've used the macro to say that this is going to be the entry point. So that's our starting point within the program. That's a starting function, and as always, you can see that we have the usual arguments going into that into the entry point. Sorry, let me just quickly. Okay. We have the usual arguments going into the function, as you can see there. And we can see the result. The return type of this function is going to be program result, which is going to be either an error or okay. And in fact, this function is very simple. It's really just a wrapper, I suppose, just acting to sort of push the processing on. But you can see the possibilities. It's looking to see if there is an error, in which case it returns the error. Otherwise, it's going to return okay. But this is just the entry point. It's passing everything straight to the processor module and to a process function, as you see there. So what does that function actually do? Well, it's got all of the information that the entry point had, as you can see here. It's going to return a program result. So all the way through, that's what we're looking to return because that's going to be an okay or an error. But then what we do is we start to we try to get the instruction out of the instructions that have been passed in. So here we have this input here is the bytes of the instructions. So we use this to unpack that, and we are looking for a particular type of instruction. So we this is for this is in the token program. We want to do a mint, and so we've already defined what types of instructions there are possible. So this is how we know this is why we're using token instruction and using that to unpack that. In fact, you can see here the token instruction is an enum. So what this is saying is that uh, the we've got a number of potential instructions, and they're all defined within this enum. I've just got the first one here, the initialize mint, but if you look in the code, you can see the other ones. So we've got that. That's what we're expecting. So we use that to pull out the instruction from our input here. So that's what line 842 does. Once we've got that, then we match up upon that. And you can see I've just given you a snippet of the code here, but we match that against a certain pattern. So we match that against this pattern of part of the enum, the token instruction enum, which is initialize mint. Okay, so that's when we get the instruction, that's one of the possible instructions it could be. So that's what we're looking for initially, and uh, that has these parameters as well. We when we do the initialize mint, we would be providing the number of decimals, the mint authority, and the freeze authority there. And you can see then that if it matches against this, if it is an initialize mint instruction, then we are going to do the expression after the arrow here, which first of all we just print out a message to say that's where we're going, and then we actually call a function to process that. We know that we do want to do initialize mint, so now we can actually be specific and call a function that is going to do that, and we pass in the details well, we pass in the details here. We've matched from the instruction, which are decimals, mint authority, and freeze authority, we also pass in the accounts that we had as a parameter to the process function. Okay. So this I've already shown you. This is a enum to have the possible instructions in it. So that's used there. There's also, mint2, for example. And this is what would the mint2 would look like if we matched against that. So I've just shown you here different parts of the enum and then how these are used in the match, how these are used as a pattern in the match block to then choose which function to go to. So if our instruction is a initialize mint, then we go to process initialize mint. If our instruction is a mint2, then we go to process mint2. Okay. So if, for example, it is mint2, then this is where we are going to be sending some tokens initially, creating some tokens and sending them to an initial account. So again, we're passing in the details that we've got from the entry point again. We've got the program ID, the accounts. Then also we want the amount that we're going to mint to, so we need that, and we have this thing of the number of decimals that are expected. Now, in order to do this, we need then to handle the accounts that got passed in to our program. And so we go through this same process here that we can get an iterator for the set of accounts. Then we get the next or the first account, which is going to be the mint info account. Then the next account is the destination account. And then the one after that is the details of the owner. Okay. So that's what we're expecting to be the accounts if the instruction is the mint2. Okay. So we've just got an iterator and then from that pulled out the various accounts from the set of accounts that we've got. We can do some checks there. So we're checking about if it's if it's native, then that's not allowed. The other point here is we need to look at if you remember when I was talking about doing a transfer, you need to be checking the mint account and making sure that that's the same for the origin and for the destination. So we can look at that. We also look at the number of decimals that we think should be there as well. So that should match up there. Other things that I think this is probably the end of that mint2 part there. We we need to. I'm sorry, I forgot what this is. This is checking to see making sure the signatures are correct. So we're doing a mint2. We therefore have to check that we are allowed to do the minting. So we have a mint authority, so we're checking that we are the mint authority. So we need to do that. So these are some of the checks that need to be carried out within our logic before we can do the actual minting, before we can actually transfer the tokens. And then once we've done all of that, we can actually make the change and we can make the change, and then we have to pack the accounts back. Once we've made the updates, we have to pack all of our accounts again. We've already got the accounts unpacked, and then we have to make the change and then pack them again once we've made the change. And then that is the end of our state change. So then here on 577, we can do an OK to say yes, if we've got this far, then everything's worked. We've really reached the end of the process for this particular instruction. Um, so we can return an OK. All right. So there's quite a lot going on there. Do have a look. The main thing I wanted to show you really was to give you a flavor of the what it looks like to in a more complex example, what that looks like, how you handle instructions, how you can do checks for access, whether the person is allowed to make an update, that kind of thing. And then the fact that you can make an update and then you pack the data back into the accounts, and then that's everything finished. Okay. All right. Let me move on. So I want to talk now about PDAs again, and this is to explore the kind of some of the patterns that you can use with PDAs. We're going to see more of this later, so we've got some more examples that you'll see, particularly when we're looking at Anchor. Or when we're using the Anchor framework, we'll see more examples and will for particular use cases. So you'll get some more idea then as well. But I want to go through to give you an idea of what you need to think about when you're thinking about PDAs and when you're thinking about the seeds. I mentioned yesterday we have this idea of a seed that is used when you are finding the address, the special derived address. And I said that we need this because we want to be able to have multiple addresses for a particular program, but I didn't really say anything about how you would choose that seed or what that seed should be. So that's what we're going to look at now. So the the excuse me, the code here. This is in fact some JavaScript. So we can do this on the client side. And again, I mentioned this yesterday, the fact that we may need to work out the address. We may need to find the a PDA address on the client side, even though perhaps we're going to create it on the program side. We can also create it on the client side, but because it's deterministic, it doesn't matter. We can do it again, and the uh, the runtime will need to know the PDA address if that's going to be used. So if the client is going to use that, we'll need to pass that address in. So uh, yeah, we've got details here. This is what it looks like on the client side, some JavaScript. This is what the instruction you could assemble to actually do this. And what this is doing is creating an instruction which is going to be put into a transaction. And you can see that in order to do that, we need various keys for the accounts that are going to be involved. We need to specify the accounts we want. So, for example, we need to say who is going to pay for all of this. So that's the account here. Um, this is an account that we're going to initialize. So this is going to be the PDA that we're going to create. But we also need to pass in details of the system program because that is going to be used to create the account. The system program is the program that creates accounts. So we need to pass in details about that. So our instruction needs to be created containing this information. And there are various flags that you're going to be setting. For example, here we've got the fact that the person creating this instruction is the payer, so they're going to be signing for this because they're going to be paying for this transaction. Um, but uh, the account that is being created is not a signer, and the system program is not a signer in this instruction. So yeah, that's why we've got it set up like this. Um, the other things we need, the program ID. So when we create an instruction, obviously we need to know which program is being called. Um, and then we can also send in some other data. This is going to have data about the size of the account that's going to be created. once we have created an instruction, then we can add that to a transaction. So you can see here, we're creating a new transaction and adding in the instruction. Um, and once we've got that, then we can send that off. Um, and we're saying that we are the payer. This is the payer account for that. Um, so that's a way to do it from the client side. If we want to, we could also do this or get the program to do this. So um, this is calling um, the system program. This is calling the system program directly. So this is creating an instruction to say that we're going to call a system program rather than uh, our program. We're calling the system program here, and then we're sending in the details again of the account that we want it to create. Okay, so we've got the address that we want it the account to have. We can pass Lamports to it. We can tell it the size of the program, um, and yeah, that's the program ID that's associated with this. And then that program can then uh, uh, do a cross-program invocation call to call the system program to actually do the creation. Okay. Um, so there's quite a lot here. So I think it's perhaps a little complicated, but um, yeah, I just really wanted to show there are different ways that we can set this up. Perhaps I'll talk about the seed selection next, and maybe we can come back to this. Particularly, we can come back to it next week when we look more at the JavaScript side. Uh, but the the seed selection I wanted to talk about because this is something you do need to think about when you're using PDAs. You need to think about how you're going to choose a seed for your particular program, and it is quite dependent upon the type of application that you have, what your application is trying to do. So it makes sense. You can't sort of decide this generally. It's you make this decision when you know what type of program you're writing. And to illustrate this, I've got an example. If you imagine you're writing a program that is going to take bookings for a restaurant, and uh, we would we could have our program, so our restaurant program here, and then that would need to store data about as it's processing. So it would need an account. So we've decided we're going to have a PDA in this case for our program. So we're going to use this to store details about the restaurants that we are going to have within our application. Now, given that, what would be a good seed to use when we're deriving an address for this account? Well, one thing we could do, perhaps the simplest way that we could do this, is to use a counter. So if we think that for this program, we're going to have multiple PDAs because we'll have multiple restaurants. So how we can differentiate them from each other is that we could have a counter so that counter would be the seed so that when we create the address, we would each time we create the address, we would have a different value for the counter. Therefore, the address will be different. We want to make sure that each time we derive a PDA, we get a different address. And so a way to do that is to change the seed, and it would make sense to change that in a predictable way by, say, using a counter. So we've got an example here of what that could look like, where when we find the address, we pass in the program ID, of course, because it's relating to this program. We use the counter as the seed, and then we have the usual seed bump as well. Now, what that would mean is that as restaurants were added, we would the first restaurant would have a counter of 0. The second one would have a counter of 1. And so, this will change, so we'll get different addresses. Um, the problem with this, I mean, it's conceptually quite simple, but the problem is that we need to keep track of the counter. As we're adding restaurants, we need to know what the counter was for the last restaurant so that we can update that. So we also would need another account for our program that will be holding the counter. Okay. So that's not terrible, but it is one drawback to this approach. One advantage to this approach, though, is that imagine we have a number of restaurants, maybe 20 restaurants that have registered with our program, and we want to go through them, iterate through them, and get back the accounts associated with each restaurant. Well, that is quite simple because, excuse me, we know that that's just based on the counter, and so we can just provide the values within the counter and just iterate through, updating the seed each time to get the addresses, and then use that to find the accounts that we've already set up. So it's quite simple, and that could be, we could be doing that on the program side or on the client side. The client can do the same process because it is deterministic. The client will know the program ID, and they know it's just based on this simple counter, and they we can make the seed bump known. So that is quite simple. We could easily then iterate through the accounts on the client side. Okay. Um, The final point here, yeah, of course, you need to make sure you're not going to exceed the size of the counter, but unless you choose a very small data type for the counter, then you should be okay with that. So it's probably not going to be a problem. But that's not the only way that we could do this, the only way that we could specify the seed. Another way to do it, which ties in quite closely with the way that this program is working, is to have the seed for each restaurant to be the public key of the owner of that restaurant or their wallet. So each restaurant will be different, will have a different key. Therefore, if we use that as a seed, that will work. That will mean that we'll get a unique PDA for each restaurant. So that's good. Um, it means we don't have to store the account anywhere. We don't need any other account to hold any other data. All that we need to know is the details of the restaurant's public key. So that's good. So when we're creating it, it's kind of simpler. But the problem is that it's then difficult to iterate through the accounts that we have because then we need a list of all the keys from restaurants that had ever been used. So in that way, it's not, that's not as simple. That's a drawback to that. But the point I want to make really is that we've got two possibilities here. I've just given you two examples, but you can use anything as a seed, but you choose something that makes sense within your application. Choose something that is going to be simple to be used or that makes sense with the logic within your application and the type of application that it is. Okay. Um, Now that was just a simple account for the restaurant, but this could go further down. This could go sort of more levels deep in terms of the information because we could have something like this where we have a PDA for the restaurant, but then a booking will be made for that restaurant. Now, we may want to have that booking as its own account and not stored in the restaurant PDA. That would fill up. We wouldn't want that to happen. So we would probably want a special separate account for the booking, and similarly maybe for the bill as well. So we would want a number of PDAs involved, but one advantage that we get once we have the PDA set up for the restaurant, that could give us a starting point for the seed for the next item down. So you could uh, you could use the booking PDA could use the PDA of the restaurant as a seed, perhaps with a counter as well. Depends if there's going to you probably will have more than one booking, so you probably excuse me, you'd probably want a counter within the restaurant PDA. But you could contain all of the data there that you need to then derive a booking, and similarly with a bill. So the point is that you know when you choose your seeds, there may be existing information that you can use, but it again it depends upon the semantics of the application and how the data goes together here. As I said, you know the way you look at booking depends upon whether there will be more than one booking for a restaurant, and yes, that's probably the case. So therefore, we may well want to counter within restaurant. Okay, so that's the idea. Of course, you could sort of this is designed, in a linear way. You could design it a little bit differently. Perhaps you would want to have the bill and the yeah, maybe the bill owned by the restaurant as well. But yeah, so you can fit these things. You can do these things differently depending um, on on the semantics of your application. One thing just to be aware of in case you get an error, um, you just need to be careful if you are deriving the if you're deriving the PDA within a client and within a program, you just need to make sure that that's going to be in sync. Otherwise, you can get an error like this. So just make sure that the information you're using to derive the PDA is the same in your client as it is in the program if you're going to use it in both places. Okay. Okay, so that's a few details about PDAs. There was quite a lot there, but really the main thing I wanted to show you really is the way that we can choose a seed to derive our PDA, but that's probably going to depend upon the logic of the application, how the application hangs together. Okay, so that's that. I think then that's the end of the notes for lesson 8. I hope you found it useful. Thank you for your attention. Thanks, everyone.